So good day everyone. The topic that I will discuss to you today is about the electromagnetic induction. So electromagnetic induction, which is the ability of a magnetic field to create a current inside a conductor. Now, scientists like Hans Christian Ørsted have already shown that if you have current in a wire like this, it creates a magnetic field. And that magnetic field could affect this compass needle, which is really a small little magnet, and so current can produce magnetic fields. But what scientists like Michael Faraday wondered is, could you take a magnetic field and produce current from it? In other words, was the opposite true?
And this is the apparatus that he used to study that. And so we basically have two parts. We have a ring of iron, but on the left side, we have an electromagnet. And so you're going to connect this to a battery, and that is to produce magnetic fields over on the left side. And so the hope is on the right side that could produce current inside these wires, and then we would be able to measure that using a galvanometer. And so he set it up like this, and then he closed the switch. And so watch what happens to the current in the wire on the right side as I close the switch. And you can see that we generate a little bit of current, but then it goes away. And this is puzzling. So he opened up the switch, and watch what happens. We have a little bit of more current, but it is in the opposite direction. So let me kind of close that switch, and we have a little bit of current, but it goes away. And then we open up the switch, and we have a little bit of current, but it isn't going the other direction.
And so that is electromagnetic induction. But what he wondered is why it is only occurring right when I close the switch. So to understand that, you really have to understand the specific of electromagnetic induction. And to understand that, you have to understand what magnetic flux is. Magnetic flux is how a conducting material for that matter is affected by a magnetic field. And so what would be something similar? It would be how any material on our planet is affected by light from the sun. And so it is going to be the amount of light from the sun, but it is also going to be the angle at which the light beats.
And so magnetic flux is going to be the product of the strength of the magnetic field, how much or how large that magnetic field is, and then we are going to multiply that times the surface area perpendicular to that magnetic field. And so imagine that there's right down here is a wire loop, and so a little bit of a wire, and we could get a magnetic field. And so if we ever have change in that magnetic flux, then we are going to have electromagnetic induction occurring. And so what happened right when he closed that circuit? Well, the magnetic field before he closed the circuit was zero, but then he added this magnetic field. So was there change in magnetic flux? Yes. And so was there electromagnetic induction? Yes, so it created current. What would happen if we were to increase the magnetic field? So let's double the magnetic field. Well, for a moment, as we are doubling the magnetic field, are we getting a change in the magnetic flux? Yes. Are we getting induction? Yes, and therefore we are going to have current in that wire. And so by varying the amount of that magnetic field, we can get inclusion, or we can get current in that wire. Now, what is the another way we could get that? Again, we could look at the surface area that we are impacting. And so if you think of this as where all of these magnetic field lines are perpendicular to this wire. And so we are going to have a large magnetic flux. But watch what happens when I turn it at an angle. And a good way to do this is simply want these lines of the magnetic field that is hitting. You can see that there is a reduction, and so the number of lines is different, but also these are not hitting it straight on. It is not perpendicular, so we can use a little bit of trigonometry to figure out that component of that magnetic field is actually perpendicular to surface area. But did it change between to those rotation? Yes. And so was there electromagnetic induction? Yes. And so there would be current as well. And so let's have we turn it out like this, the magnetic flux is going to be zero because none of these magnetic field lines are going to be perpendicular to the surface. But if change those 2 points, and so we are going to have induction and we are going to have current.
So that seems a little non-intuitive, but it has a real-world application. And so the electricity that you see right now at your home and the microphone that I am using right now in the camera use this idea of electromagnetic induction. And a great way to look at that would just be looking through a generator. And so, how does a generator work? Well, in a magnetic field, what can we do is we can take these wires and we can start to rotate them. And as we rotate them, we are getting huge changes in magnetic flux. And so, we are going to have a huge changes in the current itself. And so, if we look at the equation,
And so if you look at the equation, magnetic flux, or phi sub p, is going to be a product of the magnetic field, how big that magnetic field is, times the cross-sectional area perpendicular to that magnetic field. And so if I take this wire right here and I compare it to this wire right here, which one is going to have a larger magnetic flux? Is it going to be on the left? And the reason why is that we're going to have more of the magnetic field lines go through it. What is a good way that we could increase magnetic flux is we could just wrap that wire bunch, and so each of those wires we are going to have the magnetic flux of that individual wire. And so by changing the magnetic field or by changing the size of that area, we can change magnetic flux. But also remember, we could angle it. And so if I angle it like this, we have fewer of those magnetic field lines so through it, and so we are going to change the magnetic flux, and would actually have magnetic flux, but it's not a measure of magnetic flux that is important in producing current. It is, are we getting change over time. And so this is PHET simulation that gets at that. And so we have magnet over on the left side, and then on the right side we simply have a wire hooked up to a galvanometer, or it is a voltmeter. It is going to measure the amount of voltage, and you can see that there is no current right now. But as I start to change that position of the magnet, I am starting to get current. And you can even see the electron moving in the wire. And so if I increase the number of wires, I can increase how much I am deflecting the needle, how much current I am actually moving inside the wire itself. Why is that? Now, the magnetic field lines, you can see the magnetic field lines are changing, and as they change, we are getting change in magnetic flux, and so we are getting current inside the wire. Now, another way to look at this would be through a generator. And so in this setup, what I have is a magnet down here on a wheel so that I can spin that magnet. I have my wire again, and I'm trying to induce current inside that wire. And then I am going to measure the amount that I am going to change. And so watch what happens now when I start to turn on the water inside that faucet. Is it changing the position of the magnet? As it changed the position of the magnet, it changed the magnetic field. You can see the magnetic field lines are changing, and so I am starting to get a little bit of current. Watch what happens if I increase the speed of that water. I am getting more current. You could even have a light bulb connecting to it. And so now I am starting to get a usable energy. Watch what happens as I increase the number of wires. I even have more energy coming out. Now if I increase the water again, I even have more energy being produced. And so we are taking that energy of the flow of the water and actually making electromagnetic energy out of it.
and so this is how the generator in a dam would work. We have the water flowing down through the dam. It is spinning these magnets and it is creating that electricity. So that would be all this day. I hope you have learned a lot about the topic of electromagnetic induction. Thank you.